hopefully. Yep. Let's start. Now I'm gonna present a slideshow. We have a very short slideshow about the Go and the Go background, which then we will be diving into more coding stuff and learning by practicing. So let me share the screen. Are you able to see the screen? I assume yes. Okay. Thank you, Vladimir. So hello again. Today we're going to talk about the Go's background, and we're going to check if we have the Go in our machines. If not, we're going to install it. We're going to talk about what kind of projects are using Go and what kind of companies are using Go as well. Some short brief introduction, basically, and then we're going to dive into writing some code. After the presentation, I will be sharing my code editor, and then you can basically follow through what we're doing. And but if something goes wrong, please feel free to interrupt me, and we can take a look and try to solve this problem. Because this is a workshop, it can be interactive. There's no problem. And yeah. Okay. So once again, welcome. We're going to go about some background in Go programming language. So Go is an open source programming language that was initially started in Google by a couple of engineers. And the reason why they have actually built Go at that time, that Google's requirements, especially for their team, was a bit, let's say, complex, and there was a lot of structures that they need to take care of. So they built Go specifically for targeting those problems, and they were always putting some pressure and effort to make the programming language, the Go, a very developer friendly one. That's why until this day it still secures that position, in my opinion, and the community also thinks in the same way. So it's still supported by Google. Right now it's open source, so there's a lot of contributors to it. Even you can actually contribute to it if you get to know the ecosystem a bit more. And it is built for basically building simple, secure, and scalable systems. And it's been used in a lot of companies, including my previous company. It's easy to learn, really. The syntax is not that very complicated. And the standard library, which is the, let's say, the out-of-the-box included tools coming from the programming language, is also quite user-friendly. And to build programs, it's also like very straightforward. There's not much boilerplate code, which means like template code that you need to make, or there's not much things to install, like configure. All these stuff are very basic and straightforward, just to keep the developer experience in a nice spot. It has a built-in concurrency and robust standard library, as I mentioned. Concurrency means here basically Go has, let's say, support for making sure to use the host machine's resources efficiently and not waste any of them, which means that you can actually, let's say, run a process. And if you need to run this process for 100 objects, let's say, you don't have to actually do this in a synchronous way, which means like do one by one. You can actually do hundreds of these in same time. But of course, this depends on your host machine's availability, your CPUs, cores, threads, etc. But nowadays, all of the modern infrastructure machines are quite capable of a lot of processing power. So Go actually makes use of this. It has a large ecosystem of partners. One of them is Google, and the community is quite active. And there's a lot of conferences and speeches about it. And the tools, of course, it has a nice, let's say, package library. We call packages tools, so they're kind of equal things. Basically, it's things that are built by other developers, by third-party developers, and made available for your code to use for specific topics. For example, to connect to a database, you need a driver. So you need to install a driver tool, a package to use in your code. And there's a lot of these. So yeah, as you can see, these are the companies that are using Go. There's Google, PayPal, American Express, the ones that I know, Bitly, Dropbox, Cloudflare, Meta, Microsoft, Twitch, Netflix, Twitter, Uber. As you can see, all of these companies are providing services that are highly scalable, which means they can actually take care of a lot of users at the same time. We're talking about millions, hundreds of millions of people here. So that's why your applications, when you have such amount of audience, have to be fast and reliable at all times. There's a lot of course, strategies behind this, but also having Go as a fully compiling language into machine code right away without any intermediary compilers. It also helps with the DevOps situation because basically you can build your applications faster thanks to this ability. I will be sharing this slide with all of you guys. Basically, here we have some 4 categories, which has different kind of projects that was built by different companies and or yeah, even there's the government UK side, which is basically they're using the APIs and they made their whole endpoints made by Go. So basically, the government of UK is using actually Go. For the cloud and network services, Google Cloud is using Go, and actually the Kubernetes is also built with it. So it's really related with the CLI. But as you can see, there's not only one thing that you can build with Go. You can actually do cloud and network services. You can build CLIs, which means like the tools that you can use from your terminal. You can do web development. You can make REST APIs. I don't know. Caddy is actually like a whole web server, so that also is built by Go. And for the DevOps and site reliability, Terraform is also using Go. And there's YouTube Sweet Test, but now it's actually used by PlanetScale. But yeah, all of these links are available from the slides that I will be sending you. So if you like to dive in a bit more, but they're really short reads, so it shouldn't be really a problem. You can check them. Okay, so we need to install the Go in our machines if we don't have. Could you please let me know in the chat, do you have Go installed in your machine right now? Okay, Raquel, what about you?
Nope.
Okay. Okay, right now I'm gonna put in the chat this link. And once you click there, let's actually, let me share that screen as well. We can go together. It should take you to this page. Basically, you can actually install multiple versions of Go, but for now, we don't really have to. We can just download the latest long-term support version, which, as I see, it's 1.21.4. So we can install that. You have also different, let's say, instructions based on your host machine's operating system. So I'm using Mac, but if you're using Windows, there's also some instructions here. And don't worry, actually, it's quite simple. But to basically download the one that is for you, when you click the download button, it takes you to this page. And on this page, there are featured downloads. So, but you can just go down and you can see the Go 1.21.4. And here, there's a kind attribute here, and you would like to install the installer version, okay? So if your operating system is Mac OS, just click on this Darwin-AMD64. If not, then, for example, if it's also ARM architecture, you can download this one. ARM is for basically Apple Silicon M1 chips, and the x86 and 64 is for Intel chips, which is the older versions of the MacBooks. But if you have Windows, basically you at the end here, you have this installer. You just have to install this. Once that is done, you're going to run the installer, and it will take care of everything, basically. So just to show for some example purposes, as you can see, I have this. You don't see it, though. Let me share my screen again. Okay. So here, I have it downloaded. And once I click to it, as you can see, it actually automatically detects that there was a previous installation, so that it will basically remove the previous installation and then replace it with the newer one. And then you just go through all of this step. I'm not going to run this because I have the latest version actually, so but let me know if you ran into a problem. And if you would like to share your screen as well, I can give you the rights too, so it's not a problem. Everything cool? Okay, super, Vladimir. What about you, others? Super. So we can actually go to the next slide to make sure that we have the script, sorry, the Go version is correct and we have it installed. Please run a new terminal from your machine. If you're using Windows, it could be PowerShell as well. And then you can basically run this Go version command, and it should give you the version of the Go installed in your machine. Let me know if you can see if there's a problem. Also, please raise it up, we can fix it. All good. Gonna wait 1 minute for the others. Everything good? Okay. Feel free to interrupt if there's something wrong, and I think we can go on with the code itself. So from now on, I will be sharing my Visual Studio Code. If you don't have it installed in your computer, also you can do it by going to this link I will be providing you now, but you probably have it. If not, please do download it now. And then we're going to set up some extensions in our Visual Studio Code to work together with Go. Okay, now I'm going to share. Super. I believe it looks a bit weird, right? Let's make it bigger. Yep, super. This is better. Black screen still. Okay. You don't see the code editor at all? Okay, let's try again. What about now? Do you see the screen? Okay, give me 1 minute. Let's fix that. I have an idea that might fix it, so. Okay, what about now? Oh, that's a bummer. I'm able to see it, but no, not sure why it's not coming to you. Still nothing? I'm checking some. That's really weird. Let me re-enter the room and try again, okay? Just give me a minute. Okay, I was muted, so it should be working now. All right. So to basically start with, you can create a folder anywhere you would like to, named Learn Go with TDD. This will be basically our whole project throughout the workshop. We'll be adding subfolders into this main folder uh, in the meantime. So once you have this folder, we're going to create, you can open this folder with the Visual Studio Code. And once you've done that, we're going to install some extensions here that will help us. So here, basically the only one I have and which takes care of everything is the Go extension. And it's by the Google team. As you can see, once you install this, there's a bunch of things that is actually packaged. So it actually provides IntelliSense, some code navigation and editing, as you can see here as well. It's quite nice. It will really help the speed of the writing the code. Okay, let me know when you install this extension. Basically, you go here at the left tab, and then just write go and then install it. Also, let me change the color palette here. I feel like it's too dark. This one's better, probably. Okay. So once you get that done, let's start coding. Let me open it up here. Okay. All right. So traditionally, every programming language that I have learned actually has these tutorials where they actually teach you how to write the hello world text to some standard output, maybe in the as a JSON format response of an HTTP request, or just simply to the terminal itself, to the std out. So that's what we're going to do. Actually, we're going to learn how to write the hello world with the Go. So basically, after creating this Learn Go with TDD folder, we're going to make a new file from the Visual Studio Code called hello.go. And also, just to make it as a disclaim, that we're going to learn Go with the TDD. TDD means test-driven development, which means actually in traditional ways, testing is very important in software development lifecycle when you're building a product, because that actually ensures the product is resilient to many scenarios. But in traditional ways, the tests are written after when you actually write the code. I can zoom in, of course. How is this? Is it better, or do you want me to zoom in more? A bit more. How about now? Okay, super. So traditionally, basically, after you write the code, then you write the test. That means your code is actually driving your tests. So the test should drive the code, because the tests are the contracts that tell us what the code actually should do. So because usually when you're building a product, you have some acceptance criteria given to you by your product owners or some other members in the team. And you have to actually write some software that is aligned with these requirements. Since you have these requirements, you can actually create some test cases based on these requirements. And once you actually go with the test-driven development, your code is so resilient because you put the scenarios first and then created your code to make these scenarios pass. This means that your code is actually resilient, and it actually helps us to catch some bugs that we could miss in the traditional testing ways. There are a lot of resources that you can read about the TDD. I will be sharing some of them after the event, but let's start with the coding section now. Okay, so after creating the hello.go, what we're gonna do is we're gonna define something at the beginning. So packages in Go is a way of basically grouping up your code, okay? And there's a one special package type, which is called main. Package main means this file belongs to the package main, and package main is the initial, let's say, entry point of our program. There are many things in different software languages. For example, in .NET, C#, you have the program.cs, which is your initial file. So you can think that as this file, okay? And in package main, we're going to have a function, again, a special function called function main. And this is basically the actual initial place of our program. So anything that we will write here will be written or executed first. So after we make this function, we would like to basically print out the hello world to the terminal. And to do this, we have a built-in library called FMT. And as you can see, since I have the extension, there's an IntelliSense about the packages as well, including the standard library. So there's FMT and FMT sort, but I would like to use the FMT. And after I put the FMT dot, I would like to call FMT packages print ln function. Println is basically print line, which means it prints a string text that you gave into the function, and also a new line indicator, so it will be putting a new line at the end of the string. So here we're gonna put a string quote, and then we're gonna say hello world. Now note that I haven't still saved my file, but since I have the extension of Go, if I save, it should remove this squiggly red error because it says undefined FMT. This is a compiler error. Go is a compiled language, and compiler will help us most of the time when we're writing code that there is something wrong with your code, so fix it. So always listen to your compiler. That's a very important message I could give to you. And what does this mean is that, okay, you're trying to use the FMT in your package, but this FMT is not defined anywhere inside your package here. So we would like to actually import this FMT package. But once I save, not sure if this is going to work on your computer. I'm not sure if there was an additional configuration. The VS Code will automatically import the FMT because it knows that we're trying to use it and it's not defined here. So once I save here, as you can see, this statement appears. Let me know if it also happened in your computer. If not, you can basically write this import statement on your own as well. After writing this import, you can open a text string, press Control Space to get the IntelliSense, which kind of libraries you can get. And you can just find the FMT here. It doesn't show me because I have it already here. But once this is done, basically we're ready to go. Any questions so far? Please let me know. Otherwise, I will be continuing. Okay, I assume yet no. Then let's continue. Okay, I'm waiting. Are we good? I made a typo that I just realized. Okay, so you don't get it when you save it. Is that correct? It might be because of this. All right, so everything is okay. Also, make sure if you have something when you press Shift, well, Command on macOS, probably it's the Windows button, but Shift, Windows button, and P, you get this nice, let's say, action search bar. And once you go to the settings and search for on save, there is a format on save that you can also actually check this out. I'm not sure if it's really related with this import, but probably Go tools are doing this automatically and you need to install something, as you said. But if everything is fine, let's go on. Okay, so as you can see, I can see the hello.go file here. And when I do the LA means show me everything together with additional information. As you can see, this is the security permissions that I have to the hello.go based on the users. This is a Nix-like computer, so it's a Mac OS. That's why it shows like this. It might be different in Windows machines. And to open this, by the way, if you don't have it, you can just run to the view and the terminal here, and it will show up here. And now we can actually run the program. So here in the same folder with the hello.go file, we're going to run the command go run and then dot. Dot means like run this command inside this folder. And this is something that you should see. So let me know if you get this exact same message as I just got now. Okay, super. So basically here the error is you are trying to run something, but there's no go.mod file. And mod file in Go is basically it's about the modules. Modules is a way of basically handling the dependency management in Go ecosystem. So when I was talking about these third-party libraries, like some database drivers or some other stuff, anything that you could download from the internet to use it in your code, are dependencies. And to manage these, you have to have a Go mod file. It's something similar to packages.json if you're familiar with Node.js environments. It's something similar to NuGet packages if you're familiar with .NET. For Python, there is like a requirements section in pip file, so that kind of thing. And to basically get rid of this error and to resolve it, we have to run one additional Go command in our project folder. So you're going to write Go mod init, which stands for initialize, and then you can just write anything you would like to. So this is usually when you're writing something for the public, this is a reference link to the GitHub repository, for example, my repo, okay? It's a full URL. But for now, you don't have to do this because we're not doing anything public. You can just write learn Go with TDD very easily. And once you do this, there is a new file actually appears in your folder, and it's the go.mod file. Let me know if everything is fine until at this point. Okay, and as you can see in this file, we have the module declaration with the name that we have given, and the Go statement here stating which version of Go we are using at the moment. Since we have downloaded the 1.21.4 and initialized, and our machine is using that Go version, it automatically detects this and puts it in our Go mod file. Okay, so this is all good. Now let's try to run the other command again. And as you can see, this time there was no errors, and we see this print line statement here at the terminal saying hello world as we have put it here. Everything good? Okay. Just to give some more additional information, Go Run actually builds your code, compiles it into a binary file, which is a machine executable. So it actually transforms to an .exe or .sh based on your operating system, so that your computer can run it immediately. But if we would like to get just a binary file and not to run it, we can just say go build. And as you can see, it will create that executable file. And when I do here, you can see it. It's 1.8 megabytes. Learn Go with TDD, and it also have a execution permission, as you can see. But for now, we don't need it, so you can delete that because we're going to use the go run command. Okay. Now we're going to the test part of the code. All right. So to test things in Go, you need an extra file for the function that you would like to test. But the thing is, right now, we have to do some refactoring here because we have our domain code, which is this part that we are defining as this programmer, and then the outside world, which is like the side effects. So this is the println is the side effect in this program right now because it's coming from the outer world. So that's why we need to actually separate these. And what we're going to do is we're going to define another function called hello. And this function is going to return string. So this is how you actually define a function that returns a string. You write the func keyword, then you put the function name, and you put the parentheses, and then at the end, you write what you would like to return from this function. And then you open the curly braces, and everything is ready. To basically separate this, we're going to return directly the string hello world. And what I'm going to do here is I'm going to delete this string here. And I'm going to call this function directly. So what it will be doing is it will call this hello function, and this string value will be returned, which then it will be passed to the FMT print line, and it will do this exactly same thing. So actually, after you save it, run it the program again, and you will see the same example. Okay, so since we have separated our domain code, now we have to test this. And let's go do that. When you want to test some Go code, there are some rules that you need to follow. So we're going to test the hello.go file. Therefore, we're going to create a hello underscore test.go file. So this is a convention, and this is a convention that you have to follow because this is how the Go test CLI tool that we're going to use in a minute understands where your test files are. And once you do this, you can, again, make this package a main. So we're just using a main package for now to keep everything simple. But this could have been something like, I don't know, main test or something like this. Okay, not the main though, because main is a specialized package. But if you had something like your own, because you have the ability to make these, let's say packages, some customized name, but they have to stand in a folder where it will be the same name with the package. So that's the case. So if I had a folder here, then if any Go file here has to be in the package A package. Yeah. But for now, we're going to keep the package main. And here we're going to write a test function. I just want to check something to make sure if you have it. What happens when you write TF? Do you see this IntelliSense? Do you see these drop downs? Okay, what about you, Raquel? Okay, so this is actually a very nice and easy thing. When you do this and click on enter, it will bring that boilerplate code that you need to have. So to make test functions, this test prefix is a required thing. So in test files, you have to have test functions starting with the test word. And after this, you can just write the function that you would like to test. For example, we're going to test the hello function, so I'm going to put the test hello here. And as you can see, again, there's something undefined and the compiler is giving an error, and this is the testing package. But you can just save the file and it will automatically import it, and you will have no errors at this point. And also note that you didn't need to install any other like third-party libraries or tools, and everything is included right inside the Go. So that's quite convenient in my opinion. Okay, so once this is done, this is the testing package, and there's a T type here, and this is a struct. We will be coming to structs in the later sessions, but also don't worry about this thing here, but this means basically it's a pointer, okay? When we run the Go test, the testing tool will be passing this T function, the T struct, T objects, address reference into these test functions so that we can use actually the same T object on each test function. This is some advanced topic, but yeah, don't get confused by it. But this is the variable that we're going to use. This is how Go actually has the parameter signatures. So you put the name of the parameter first, and then comes the type. So this is the whole type of the T. All right. So basic testing function, we would like to specify what we got, okay? So what we got from the hello function, we're going to say got colon equals. So in Go, you create variables by this little fella. So this is the statement that you can actually create some variables and assign the values to these variables, okay? And what we're gonna have to do in got is that we would like to actually see what the original function returned to us, okay? This is what we got. And we're gonna say, okay, but we want, in this scenario, we would like to see hello, all right? And then once you have these two variables, you're gonna write an if statement. Notice in Go, there is no required, let's say, parentheses in if statement. So you're gonna write if got is not equal, and please, I'm doing this actually, but it's not showing up. So it's like this, but the ligatures are not allowing me to show you this. But basically, you write these things together. Not equal. If got is not equal to want, okay, this means that something is wrong, and we're gonna do error F. This, as you can see, the T object has many methods that helps us regarding the tests. And the mostly used one is actually the error F, which is, as you can see, is equivalent to log F followed by a fail. So instead of doing like log this, and F stands for format. So basically you put a format here, blah, 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 you put the format, and then you put the variable so that it will be formatted based on your format. There is an assert library, but for now we're keeping it simple and we're using the, let's say, simple if statements, okay? But there is an assert library that is very extensive and it's quite good. We will be using it in the future. So here we are going to just write the error f. So what it's going to do is going to write log f, and then it will call the fail. But we're going to pass a format here. So the formats work as so. We're going to write as an error message, hey, I got something but want something. And to put some formatting rules, we have some predefined, let's say, keywords, okay, that you can use in the format string. And here, this is the %q keyword, which means put anything as I will put here as a variable. So got, for example, put this variable's value inside the string by putting some single quotes in each side. So it will be a bit more readable, yeah? That's why we're using the %q. We're going to say got q and then want q. And since we have two formatted arguments, we're going to have to give the other one as well. Okay. So I actually put the want variable in an incorrect way to show you how the tests actually fail. So after you did all this part, go to your terminal and run the command go test. And you should get something like this. Let me know if you get it. Yeah, let me actually fix that, Raquel, because I know that this is a problem. It's a thing called font ligatures. So now it should look like this. This is what you need to write. But it's like a decoration thing for about fonts, but yeah, it shouldn't be a problem. Okay, you got expected package found E of F. Did you define the package at the test file, Vladimir? Okay, and is it package main? Mm-hmm. Hmm. And you ran the go test function command, is that correct? Okay, that's weird. Let's see. Okay, can you try to save the file? Did you save it? With Control S if you're using a Windows. Is it working now? Hmm. Okay. But basically, as you can see, the test actually failed, and this is what we wanted. And as you can see, this is the message that we got. It says, hey, I got hello world, but you wanted hello. And actually, this is correct, but I just wanted the fail scenario to show. So once you put the actual want value here and then save again, and then run the go test function, it will show you everything is okay. So everything is passed, and this is how much it took. Any problems so far? Okay, super. I want to show you one more thing. Yeah, let's go on. So this is a very simple function, but we would like to, let's say, do the TDD version because we were actually doing the traditional testing concept. We wrote the code first and then we wrote the test after, but we would like to do the exact opposite way. So that's what we're going to do now. So here on our test function, we're going to say, we're going to have an input to the hello function, okay? We're going to write PDSC, for example. And then here on the want, I would like to see hello GDSC. So basically it will say hello, comma, space, and the input that I have put it in the hello function. This is what I want from the function to complete. And I'm specifying this on the test as the first thing. And here I get a compiler error, even if I, for example, try to run the Go test. As you can see, the compiler error says in hello underscore test.go file 7th line, there's too many arguments in call to hello function. You have a string argument, one string argument, but the function wants nothing. So the build has failed. So since we have provided what we wanted, we have to write the minimal code that this, let's say, error should go. Okay, this is like an iterative way. So to fix this issue, we're going back to the hello.go file, and we're going to say, all right, this function is going to get a parameter called name, and it's going to be a string type. And as you can see, if I run the Go test again, and this time it will say the same thing for the hello.go because we also use it in the FMT print ln. So for now, let's just pass it as a very empty string to get rid of the error in the main function. So because we're interested in the testing here. After doing this, as you can see, there's no compiler error. Let's say Go test again. And here, as you can see, the test failed because we put hello GDSC as the input, and we expect hello GDSC, but it says it still gives us world and not the hello GDSC. So since this is the case, okay, we're going back to our code again, and we're going to fix this. And how to fix this is to just delete this world word from here, and then we're going to put a plus sign, which means we're going to do string concatenation, and we're going to put the name value here. And once this is done, let's run the go test command again. And as you can see, our tests are passing, which means our function is now complete and doing what we actually wanted it to do. So, any questions? Would you like me to continue a bit more, or are we good for today? Yes, Raquel, please let us know. You can unmute yourself, by the way, or even share your screen. That's not a problem.
Oh yeah, I forgot I have this. I still getting failed the test. I'm not sure what I've done wrong. Maybe I'm gonna share the screen.
Yeah, sure, please go ahead. I stopped my screen now.
Can you see?
Yeah.
So I think I got everything here. Okay.
Yeah, but please make sure you save the file.
Yeah, that's what the first thing I did. Control saved.
It didn't, because when you do Control S, it saves the current file.
Mm-hmm.
To save everything, I think it was Control Shift S, but you can just switch back to that file and then save it again. Oh, sorry, Control Shift S is save as probably.
Yeah,
Never mind, just use Control S.
I I did it both ways though.
But the hello.go file, as you can see, VS Code shows a circle. That means the file is not saved. The first file in your editor, hello.go.
Mm-hmm.
You see there's a tab like a thing on the top. Yeah, and now the circle is gone, which means it's saved now.
Mm-hmm. Okay. So now let's try it again.
Yep. Yeah, as you can see, it failed because it wants hello GDSC, but it got with the comma. You forgot to put the comma on the want string. No, everything is fine
Mm-hmm.
here. Yeah,
Yeah,
on the
here.
test.
I thought I didn't put a comma. Okay, that might be the error.
Save it
Yep.
again,
Control S.
and let's see if it will work.
Great.
Okay,
Awesome. Thank you very much.
super. Okay, I will stop the recording now.